Have you ever heard that light always travels in a straight line? Well, that's not entirely true, and the reason why is one of the most mind-bending ideas in all of science. Stick around, and I'll explain why gravity can actually bend a beam of light. It all goes back to Albert Einstein and his theory of general relativity. Before Einstein, our understanding of gravity came from Isaac Newton. For Newton, gravity was a force, a mysterious pull that objects exert on each other. A big object like the sun pulls on a smaller object like the Earth, keeping it in orbit. Simple enough, right? But this view had a problem. It couldn't fully explain certain observations, like the exact orbit of the planet Mercury, and it said nothing about light. Since light was considered massless, Newtonian gravity shouldn't affect it at all. But Einstein came along and completely flipped the script. He proposed something radical. He said, gravity isn't a force pulling things through space. Instead, gravity is a consequence of mass and energy warping or curving the very fabric of space and time itself. Imagine a flat, stretched-out rubber sheet. That sheet represents space-time. Now, if you place a heavy bowling ball in the middle of it, what happens? The sheet curves and dips down around the ball. This curvature is what we experience as gravity. Now, if you roll a small marble nearby, it won't travel in a perfectly straight line anymore. It will follow the curve in the sheet created by the bowling ball. That's essentially what planets do when they orbit the sun. They're not being pulled by a force. They simply following the straightest possible path through the curved space-time created by the sun's immense mass. So, where does light fit into this picture? Well, just like the marble, light also has to travel through this curved space-time. Even though light is made of photons which have no mass, it still follows the contours of space-time. So, when a beam of light from a distant star passes near a massive object like our sun, its path gets bent. It's not because the sun is pulling the light, but because the light is following the curve in space-time that the sun has created. This effect is called gravitational lensing, and it's not just a theory, it's been proven many times. The first confirmation came in 1919 during a total solar eclipse. An astronomer named Arthur Eddington led expeditions to observe stars that appeared very close to the sun in the sky. Normally, these stars are impossible to see because of the sun's brightness. But during the eclipse, with the sun's light blocked, he could photograph their positions. He compared these photos with photos of the same stars taken months earlier when the sun was in a different part of the sky. And he found that the stars' apparent positions had shifted, exactly as Einstein's theory predicted. The light from those stars had been bent by the sun's gravity on its way to Earth. This was a monumental discovery that catapulted Einstein to worldwide fame and confirmed that he had uncovered a deeper truth about how our universe works. Today, astronomers use gravitational lensing as a powerful tool. Massive galaxies and galaxy clusters can act like giant cosmic telescopes. Their immense gravity bends the light from even more distant objects behind them, magnifying and distorting their images. This allows us to see galaxies that would otherwise be too far away or too faint to detect. Sometimes the lensing effect is so strong it can create multiple images of the same distant object, or stretch its light into a beautiful arc known as an Einstein ring. So, the next time you look up at the night sky, remember that the universe is far stranger and more wonderful than it appears. The light from those distant stars isn't just traveling through empty space. It's navigating a cosmic landscape of hills and valleys carved into the fabric of space-time by the gravity of everything in it. Light doesn't just illuminate the universe, it also bends to its will. Thanks for watching. If you enjoyed this journey into space-time, make sure to hit that like button and subscribe for more deep dives into the mysteries of the cosmos. See you in the next video.